Here's a function, e to the sine of x squared. Let's differentiate it. Well, x is the input to the function, and notice that a bunch of stuff happens to x. First, it gets squared, okay? And then that number, you take the sine of it, and then that number gets put in the exponent of e. So we need to recognize here that this is a composition of various functions. The innermost function is x squared. Let's jot that down. Innermost function is x squared. Now, we're going to pick a letter to represent this. We can pick any letter we want other than y, because y represents the whole thing. So I'm going to pick a new letter, let's say u. Okay, that's the first step. The next thing is, well, what happens next? After you take the square of the input, you put that into the sine function. So let me jot this down. The next function is the sine function. Now, I'm not going to write this as sine of x, although I could, and sometimes when you're looking at the chain rule, people will write that. I'm going to write it as sine of u, matching up the letter I chose for the innermost function, the first function. Since I chose u there, I'm going to write the next function in terms of u. Okay? And next, we need to pick a letter for this function as well. We can pick any letter we want, but not y, because y we're going to reserve for the last step. We'll see in a minute. So let's pick a new letter for this. I'm going to pick the next letter after u, v. Okay. So we've already observed that the input x gets squared, then it gets put into the sine function, and then you take that and put it into the exponential function. So now let's jot this down. The outermost function is the exponential function. And same as before, we could write e to the x, but I'm going to write it in terms of the last letter we used. So I'm going to write e to the v, matching up the last letter I used for the previous function. Okay? And we're going to pick a letter for this as well. But because there are no more functions, we've reached the end, we're going to use the letter y to denote e to the v. Okay. Now that we've recognized what the functions are that make up this composite function. We've written them down, and so when we've assigned letters to them, the next thing we're going to do is take the derivatives of each of these. So right here, I'm going to write du dx. We're going to take the derivative of the innermost one. That derivative is 2 times x. Then we're going to take the derivative of the next one. So here, we need to be careful with the letters. So we wrote v equals sine of u. So when we differentiate that, we're going to take dv du. The derivative of sine is cosine. And last, we're going to take the derivative of this last function here. And here we have y and v. Those are the letters here. So we take dy dv, the derivative of the exponential is just itself, and so here we have dy dv is e to the power of v. And now we're ready to write down the derivative of the whole function. dy dx is, by the chain rule, the chain rule says that you can find the derivative of a composite function by finding the derivatives of each of the component functions, as we just did, and multiplying them together. So we go dy dv times dv du times du dx. And note the pattern here that can help us to remember the chain rule. dy dv, dv du, and then du dx. Okay, and now we just need to look at the derivatives we see. So we actually already found dy dv. It's e to the power of v. Okay. And we found dv du. It's cosine of u. And we found du dx. It's 2x. So at this stage, all we're doing is we're copying down what we see here and putting it here, what we see here, putting it here, and what we see here, and putting it here. And just keep the letters the same. Don't bother trying to simplify at this stage. Just keep the letters that you already wrote down. I'm going to erase these circles just to try to keep this neat. Okay, the next thing we do is we want to dy dx, the function we are given, e to the sine x squared, it's a function of x, and so our derivative should involve x. These letters u and v, we introduced those just to help us along the way, but now we want to get rid of them. So we want to replace the v in the exponent there with what v is, and v, we said v is the sine of u. So let me highlight here. Okay. And then I'll just write this is the cosine of u times 2x, and we want to do the same thing with u. So now, whoops. So now we'll say, what is u? Well, u is x squared. So we have a u here, and u is x squared, so e to the sine x squared times cosine of x squared times 2x. And let's just rewrite that in a more conventional order. We'll put the constant up front, 2x cosine of x, e to the sine x squared. And there's the derivative of that composite function. We find it using the chain rule. Taking care, I think it's helpful to write down the letters, to write down these steps here. And so you find the derivatives of the component functions, multiply them together, and that gives you your derivative by the chain rule. A tricky part is knowing when exactly to use the chain rule, and that involves being able to recognize when a function is indeed a composite function. A function within a function, in this case, a function within a function within a function. And sometimes you'll even have to juggle several rules at once, like the product rule, the quotient rule, and the chain rule, and that gets even trickier. But it's worth spending time practicing the chain rule in isolation.